96 gigabytes of memory. One number, two wildly different prices attached to it. Huawei's card runs about $1,400 if you know the right reseller. NVIDIA's card, the one with the identical 96 gigabytes on the spec sheet, lists for $13,250, straight off NVIDIA's own marketplace. Not a rounding error. Not a typo. A price gap north of 9 times, sitting right there in daylight. And daylight is exactly where that number starts to wobble. So this is the Atlas 300i Duo, Huawei's dual-chip inference card, and it exists because of the export restrictions that were supposed to keep Chinese AI hardware a decade behind. 2 Ascend 310B processors on one board, 48 gigabytes of LPDDR4X memory per chip, a cheaper and slower memory type than the GDDR7 sitting on NVIDIA's card, 96 gigabytes total between the two. It isn't sold outside China through any official channel. Full stop. Gamers Nexus bought one anyway in October of 2025, off an unofficial reseller, paid roughly $1,400 after shipping, then spent weeks unable to run it at all. Not because it was broken. Because the card only talks to Huawei's own Kunpeng server platform, and Gamers Nexus didn't own one yet. A second unit went to Level 1 Techs for testing. Same story, same weight. No Windows on this thing. No CUDA either, which is NVIDIA's proprietary programming layer. The software glue that every mainstream AI framework has been built around for 2 decades. No plugging this card into a normal desktop and calling it done. You'll see that 8 times number, or 9 times, floating everywhere this month, and most of it depends entirely on which price you grab. Take the cheap end of Huawei's range against the expensive end of NVIDIA's range, and the gap is 9.5 times. Take the pricier Huawei import against the cheapest street price on the RTX Pro 6000, and it drops to 5.5. Both cards carry exactly 96 gigabytes, so that price ratio is also the cost per gigabyte ratio, no extra math required. Somewhere between 5.5 and 9.5 times cheaper. Call it 8 if you want a headline. It's real either way, just not one clean number. So here's the spec that actually decides how this plays out day to day. And it's not the 96 gigabytes everyone keeps repeating. It's bandwidth, which is how fast data moves between the memory and the compute cores, not how much of it you can park there. NVIDIA's card moves 1,792 gigabytes a second. Huawei's moves 204 gigabytes a second per chip, 408 combined across both. NVIDIA's got better than 4 times the throughput, inside a card that costs 8 times as much. Capacity got the headline this month. Bandwidth decides how fast the thing actually talks back to you. 204 gigabytes a second is roughly what a decent laptop moves, on a card built for a server rack. On raw compute, the two cards aren't really trying to do the same job either. NVIDIA's card claims 4,000 AI tops using its lowest precision mode, with 125 T-flops of straightforward single precision math behind it. Huawei's card is rated around 280 tops at INT8, which is a rougher, faster math mode chips use when full precision isn't required. Different chip, different playbook, different generation of manufacturing entirely. None of that shows up in the 986 versus 986 number that's driving this whole comparison. Now, the honest part, because the 96 gigabytes doesn't work the way 986 gigabytes usually works on a single card. It's not one unified pool. It's 2 independent 48 gigabyte chips, sharing a board and a PCIe connection, not one memory space either chip can freely reach into. Load a 70 billion parameter model at full precision, and you already need more than 48 gigabytes just for the weights, before a single token of context gets added. So the model gets split and sharded across a PCIe link, nowhere near as fast as the memory bus inside NVIDIA's card. The number on the box says 96. The number that governs your inference speed is 2 separate 48s, talking to each other slowly. If you've ever loaded a big model on a single consumer card and watched it crawl once the context window filled up, that wall you hit, it wasn't the parameter count. It was exactly this kind of bandwidth ceiling, just a smaller version of it. So who is this card actually for? If you're gaming, or opening Blender, or expecting stable diffusion to run locally the way it does on a GeForce card, this isn't your move at all, because none of that software ships without CUDA. CUDA doesn't run here. Full stop. If you're a hobbyist hoping to load one big model and poke at it slowly on your desk, the bandwidth wall and the Kunpeng requirement turn that into a rough weekend before anything works. Not impossible, just rough. The buyer this card genuinely suits is a small team already living on Linux, already willing to build around CAN, which is Huawei's own toolkit sitting in the spot CUDA usually occupies. It translates model code down into instructions the Ascend chips can run. For everyone else watching this, you're just not the customer, and that's fine. Here's how the choice breaks down in practice. Pick the RTX Pro 6000 if you need certified drivers, Windows support, or a rendering and simulation workload sitting alongside the AI work. That's what the extra $11,000 to $13,000 buys you. Pick the Atlas 300i Duo only if you're already running Linux, can already get your hands on Huawei's server platform, and the 96 gigabytes matters more to you than raw speed does. Most people watching this fall into neither bucket yet. That's exactly why the card reads as a curiosity right now, not a purchase decision. Before you land on either of these two cards, there's an option neither company's marketing brings up. A lot of local model builders reach for a pair of older, used data center cards first, or a Mac Studio with its unified memory pool. Long before they touch a card that needs a Chinese server chassis to even boot, neither seller brings that up, for obvious reasons. And CAN isn't vaporware propped up by a press release. Huawei open sourced the toolkit specifically to give outside developers a reason to build for Ascend hardware, instead of walking away from it. DeepSeek shipped its V3, 2x model on September 29th of 2025 with day one support for Ascend hardware and CAN. Not a port bolted on 6 months later. Day 1. The Llama.cpp project lists the Atlas 300i Duo as a verified device today, running Llama 2, Llama 3, and Mistral out of the box. Other Chinese chipmakers piled on too. Cambricon and Hygon both shipped their own inference engine updates the same week, all racing to support the same model on the same non-NVIDIA hardware. That's a real working ecosystem. Still young. Still real. And the people defending CUDA have a fair point when they say 10 years of tooling doesn't evaporate because one card sells cheap. First asterisk, the actual speed. Independent testing on a Qwen 332B model clocked the Atlas 300i Duo around 15 tokens a second. Fine for reading along, not fine for anything real-time and heavy. Second asterisk, nobody outside China has published a clean apples-to-apples benchmark against the RTX Pro 6000 yet. Every number in this script, mine included, is still a comparison of spec sheets more than finished products doing the same job. And the biggest asterisk of all, this card is not legally for sale to you outside China. NVIDIA can't legally sell its top workstation cards into China either. Both companies are boxed in by the exact same fight. Because this was never really about one budget accelerator card. Huawei's playing a longer game here. Chips, memory, toolkit, all built as one stack, with Chinese labs like DeepSeek certifying it on day one, so a future NVIDIA export ban can't strand anyone downstream. That's the actual plan. Washington's own guidance this year, warning companies to be careful about using Ascend chips at all, is itself the tell. Nobody issues warnings about hardware that's still a decade behind. Meanwhile, NVIDIA's own price on the RTX Pro 6000 kept climbing. $8,565 at launch, March of 2025. $13,250 by July of 2026. 55% in about 16 months. Mostly a GDDR7 memory shortage NVIDIA doesn't fully control. So part of that 8 times gap isn't Huawei getting cheaper. It's NVIDIA getting more expensive for reasons that have nothing to do with either company's engineering. So here's where I land. The card itself is niche, half-finished, and legally stuck inside one country's borders. The thing it proves isn't niche at all. A 96-gigabyte inference card built entirely outside NVIDIA's stack, running a real current model on day one for a fraction of the price. That part isn't going away, whatever happens to this specific board. 2 things to watch. Whether anyone outside China gets clean, verified throughput numbers running on real hardware instead of spec sheet arithmetic. And whether CAN's open source push-pulls in developers who weren't already committed to the Chinese hardware stack beforehand. Numbers first, adoption second. It used to be whether anyone could touch NVIDIA's price on 96 gigabytes of memory. Now it's whether 96 gigabytes even means the same thing. Split in two, running slow, stuck behind a wall you can't just buy your way around.